Well, I'd like to start off by saying welcome and thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And today I'm going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models. Now, it really doesn't matter whether you're an educator at the high school level involved in CTE training, if you're maybe, let's say, a college professor, or even an industrial trainer teaching programming skills required in manufacturing, or you could even be, let's say, somebody who's with a company that's looking for ways to demonstrate let's say, a software-based solution, or just to make something like IoT concepts more relatable to your customers or your workers or what have you. In any of these cases, I think that we're going to have some meat in this presentation that's going to give you important options to consider. We're going to start off by considering the skills gap. Now, if you've happened to attend any of our other fischertechnik education webinars, you've probably heard me discuss the importance of STEM education. And STEM, of course, is an acronym which stands for science, technology, engineering, and mathematics. And at this point, it should really go without saying that STEM education is probably one of the most discussed topics in education over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help us to best prepare them to take their place in the modern workforce. Not so long ago, when, let's say, our parents or grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who would demonstrate good motor skills and a solid work ethic. But as manufacturing became more and more dependent upon automated processes and robotic control, because of this, employers are now desperately seeking individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming of PLCs. And as it ties in directly with the solutions that we're going to be looking at in this presentation, let's just stop for a minute and consider that last skill area that I just touched upon, which is PLC programming. Now, first off, for anyone who may not be familiar, a PLC, well, first off, the term PLC is an acronym, the letters of which stand for Programmable Logic Controller. But essentially, a Programmable Logic Controller, or a PLC, is a very specialized computer that's used to control the types of machines and automated processes that are typically found in an industrial setting. And this would be things such as an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems also grows exponentially. Now, to get a clear idea of just how highly prized these types of programming skills are, here's some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the United States is $78,000 per year, or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I prepared this webinar originally, I took a look at the list of current job openings for PLC programmers on nuvu.com. This was back in February of 2020. And at that time, the listings showed 15 positions being advertised with salaries of over $75,000, and two of which even listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. But at the same time as this so-called workforce of tomorrow is getting their training and preparing for the future, more and more manufacturing companies that face an urgent need right now are enrolling their current workforce into private training schools offering programs like this. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient, for example, proficient in all 5 of the primary PLC programming languages, which you see listed on the screen now, as well as really learning how to efficiently and effectively troubleshoot and address errors and equipment breakdowns, of course, more training is going to be needed. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, other options available. Things as you see, high school CTE, career technical education programs, adult continuing ed programs, vocational training, technical training, trade schools, college and university programs, and the employer-sponsored incumbent worker training programs. Now, that all being said, the question that still arises for the educator, it doesn't matter whether you're in the university or their vocational school setting, is how do you go and teach PLC programming in a way that makes it engaging and relevant to the student, whatever background they come from? And how do you get away from the dryness of textbooks and video presentations, which at one point seemed kind of engaging, but now we're all getting kind of used to it? And it's not the same as being realistic and hands-on, which is really a more effective way of teaching. But there are also other areas of focus beyond programming that need solutions for demonstrating, exploring, and understanding different aspects of automation and control systems. Examples could be things like a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. It could be a manufacturer looking for ways to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or it could even be something like a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show environment. Now, in each of these cases and more, there is a need for finding a solution that, again, is engaging, which can effectively mimic and simulate real-world automated systems. And that is going to bring us to the line of fischertechnik industrial simulations and training models. Now, these models have all been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled, small-scale models which are designed to replicate in both appearance and function various automated robotic machines and systems that are commonly used in commercial manufacturing. Now, before we begin to look at each of the models, I'm going to provide you with just a little bit of background on what fischertechnik is. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes the system unique is that unlike other popular construction systems where the components are designed to simply stack, in the fischertechnik system, it was created, well, with more of, let's say, an engineering mindset. The core building block in the fischertechnik system is designed to enable attachment from all 6 sides, as you see in the little diagram on the screen, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together using a tongue and groove system, and the hundreds of different parts available will also help builders to address very specific design needs. The fischertechnik system itself was created back in the 1960s by noted German inventor Arthur Fischer, who's known for countless innovations used in the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer is known as the inventor of the as the inventor of synchronized flash photography, and that was back in 1949. And he's also the creator of the expanding nylon wall plug, which of course we've all seen. It's usually used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, employs thousands of workers worldwide who produce many variations of fastening devices used in building construction. And they also produce numerous components that are used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, whether it's those that are intended for the retail market or those for classroom use, has always been on helping to foster an understanding of technology and how things work. Many of the products offered by fischertechnik for the education sector are what we call subject-specific sets, for example, focusing on different STEM-related areas such as mechatronics, mechanics, pneumatics, robotics, or renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik system and then perform various experiments which allow them to explore and understand aspects of that subject. There are also some sets that include curriculum and different exercises that can be used anywhere from the elementary level to even the high school level. And there are even some things that incorporate what we like to call project-based learning, where students have to work together in teams and find solutions a lot of times just through, trying different things, doing research, and a lot of trial and error activities. Now, the line of fischertechnik simulation solutions, which of course are again the focus of our presentation today, these are something much different. Again, the line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Some of the models that you're going to find in the fischertechnik simulation line will include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, high bay warehouse storage systems, and there's even a factory simulation model. And this model consists of 4 individual workstations. It takes a vacuum gripper robot, high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection. And it puts them all together to work as one self-contained material cycle. Now, before we begin to look at the models in the simulation line in more detail, I'm going to very briefly outline some of the advantages of using fischertechnik solutions. Now, I do apologize in advance, as a few of these points are things that I've already touched upon once or twice in the presentation, but in each case, I do think it's worth repeating. First off, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be, of course, again, for understanding how automated systems work, or for having a tangible physical system to observe and work with in programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, again, as I say, in both appearance and function, common automated systems, such as things like conveyor belts, sorting machines, robotic arms, and much more. Now, because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or for in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. Next, quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of these models is available in a 24-volt version designed again for use with industry standard PLCs. Now, it doesn't matter whether you prefer to use Allen Bradley controllers, if you prefer to use Siemens controllers, or if you like controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, you can pretty much name it. You can control these 24-volt versions with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language of what you see listed on the screen right now. I do want to note, though, that with most of the 24-volt versions, no PLC is included. So that means, of course, you have to have one of these controllers to be able to access one of the controllers. And all programming and programming guidance, as well as any power sources or wiring from the model to the PLC or other hardware and such, are always going to be the responsibility of the end user. Of course, this should not be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. Now, there are a couple of examples that we are going to get into at the very end of the presentation where some of this has been included. But for the first group of models, again, you will need to do the wiring from the model to the PLC. You'll need to provide the PLC itself. And of course, again, you'll need to provide the program. Now, in addition, for non-industrial users and educators who aren't as well versed in or very familiar with PLC programming, there are several models which are also available in 9-volt variations. Now, in the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are called the Robotics TXT controller, and this is used, of course, in lieu of a PLC. And in the case of these TXT controllers, each of the controllers is pre-programmed, in most cases using fischertechnik's proprietary RoboPro programming software. Now, in the case of the 9-volt models, the only additional component that's going to be required will be 120-volt power adapters, which I will mention when we discuss those models, whether you need 1 or 2 adapters or what have you. Otherwise, essentially, these 9-volt versions are, as much as any of the models we're going to look at, these would be ready to use out of the box. Moving right along. Now, if you're involved in demonstrating or exploring IoT, which of course is the Internet of Things, besides the fact that many end users on their own have adapted some of these models in the primary line of simulation and training solutions specifically for IoT purposes, Fischer Technic now also offers a special IoT focused version of the factory simulation. And this was designed specifically for exploring and understanding cloud based control and what is sometimes referred to as Factory 4.0. Now, in the case of these models, they are designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss this all in more detail a little later in this presentation. And finally, Fischer Technic simulation models are cost-effective. Now, if you've had the opportunity to shop around and look at any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice pretty quickly that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Now, compared to that, Fischer Technic simulation solutions are available at just a fraction of that price in most cases, as well as being, again, compact, realistic, and high-quality learning and demonstration tools. So with that all being said, let's start a look at the models which are available. First model we're going to look at is the vacuum gripper robot. We're going to have a video that's going here, and as you're going to see in the video, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. The model is designed to precisely pick up and position work pieces in 3-dimensional space. The model consists of 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component. When you see the arms spin around, you'll see that, and a solenoid valve. The dimensions of this model are approximately 9 by 19 by 15 inches, and it has a weight of about 7 pounds. The 24-volt version of this model, as well as all of the first 5 24-volt models that we're going to be looking at this afternoon, each have a relay board for motor polarity reversal and both a multi-pin connector, in this case 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as with most of the 24-volt versions that we're going to be looking at today, will require you to provide the PLC and the programming. I will also mention that for this and all of the other models that we're going to be looking at today, there are additional specs that are available in the detailed product listings, which you will find on the Studica website, as well as the fischertechnik.biz website that we maintain. You can also download a product brochure from there and other information. So again, if you go to our website after for any of these models, you can find more information that's downloadable, or you can also email me and I'll give you information on that at the end of the presentation. So if there's anything you want to know more about, we can get you some info on that. Moving right along, the next model is going to be the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces, along with carrier trays for each. I will mention that this particular model seems to be a favorite among educators that we've worked with who teach programming, and there's really the reasoning for that is because it gives you so much to work with as a programming teacher in regards to the movements of the picker mechanism, which has to be very precise, as well as the precision required to properly store and retrieve each piece from those little shelves, each step, of course, which requires its own very specific coding. Anyway, going back to the dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Again, this 24-volt version has a relay board for motor polarity reversal in both multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you will need to provide the PLC and the programming. There is, in this case, a limited edition 9-volt version, which is available, which does, again, come pre-wired to a pre-programmed robotics TXT controller and that one would require one of those 120-volt power adapters I mentioned before. Next model we're looking at is the multi-processing station with oven simulation. Now this model features a furnace simulation with a pneumatic sliding door. You'll see there's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components found on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of this model is the 24-volt version, for use again with the PLC of your choice with the relay board for motor polarity reversal and both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the limited edition 9-volt version in this case is connected to 2 robotics TXT controllers. So in this instance, 2 120-volt power adapters will be required for all operations. Going to let this play out for a minute. The next up is the sorting line with color detection. And this simulation features a system for detecting workpieces of different colors, and it sorts them via a conveyor belt into 3 different storage bins. Components on this model are going to be 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at before, again, the standard 24-volt version has a relay board for motor polarity reversal, and both a multi-pin connector, again, 34 pins, with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you will need to provide the PLC and the programming. In the case of the limited edition 9-volt version, it again comes pre-wired to a pre-programmed robotics TXT controller, and one 120-volt power adapter is required for use with that. And the next model we're looking at is the factory simulation. This combines the 4 models that we've just reviewed again, that being the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. Again, it combines them all into one self-contained material cycle. And the cycle that you're going to see in the video works like this. Work pieces get retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they are moved to the multi-processing station with the oven. Now, after the workpiece has been processed by the oven, it is then sorted by color in the sorting line with color detection before again being moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these individual substations previously, I'm not going to belabor it by restating them here. But what I do want to discuss are the dimensions of this model as a whole. Again, as it combines 4 individual models into one cycle, it has a much larger footprint, in this case, approximately 39 by 31 by 16 inches, and it has a total weight of between 43 and 46 pounds, depending upon whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, and again, as I said, these ship pre-assembled, Please note that this model will only be shipped flat, and that it must, and all of the factory models that we look at, because there's several variations you're going to see today, all of these factory models must be shipped flat as freight on a pallet. And I do also want to point out that as the factory simulation models in any variation tend to be in very high demand, please anticipate that you can sometimes be looking at a possible turnaround time of anywhere from 2 to 4 weeks before any orders for this model would leave our warehouse. Sometimes you'll get lucky, and sometimes we have them in stock and we can ship them out sooner. But I can tell you, especially during the summer, they get to be in very high demand because, of course, schools are ordering for the fall semester. And as well, we get a lot of businesses that do things like trade shows and what have you. So these are all in demand. Again, as I mentioned, available in the standard 24-volt version. Same thing with the multi-pin connectors. Again, 34 pins with a grid of 2.54 millimeters and so on. In the 9-volt version, I will mention before we go to the next segment, it's wired to 5 robotics TXT controllers, and because of that, you will need to get 3 120-volt power adapters because they're able to daisy chain these. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we've just discussed who will need to transport the model or who wish to protect it when not in use. Now, the travel case that you see here consists of aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model itself can remain in the bottom section of the case and still be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and it has a weight of about 53 pounds. Now, please note that even when you do purchase and use the travel case, these models still should be shipped flat if being moved, and always should be shipped on a pallet. Moving back to the regular size models, we're going to look first at a basic conveyor belt. Now, this is a transport belt and has a length of 275 millimeters, and it's, of course, used to transport work pieces, in this case with a diameter of up to 29 millimeters. Multiple conveyor belts can easily be connected to increase the length of transport as you might desire. Now, components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just under 2 pounds. And as before, the standard 24-volt variation does include a multi-pin connector, but in this case, it's a little bit different. In this case, it's a 26-pin connector with a 2.54 millimeter grid, as shown in this photo. And for a limited time, we do also offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. And in this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, but this time it incorporates a punching machine. So this features essentially the same conveyor that we just looked at, except this time with the machining station built onto it. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches with a weight of just about 3.5 pounds. And again, it's available in the standard 24-volt variation with the 26-pin connector and 2.54 millimeter grid, as seen here. And for a limited time, we are still offering a 9-volt version wired to the robotics TXT controller. And in this case, again, one 120-volt power adapter is required for use. This next model is the indexed line with 2 machining stations, and this model features a U-shaped conveyor line consisting of a milling and a drilling station, along with 4 conveyor belt sections. Components on the model, besides the 4 conveyor belts, are 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions of the model are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, available in both the standard 24-volt variation with the 26-pin connector and 2.54 millimeter grid for use with a PLC, and in a limited release 9-volt version wired to the pre-programmed robotics TXT controllers, 2 of those there, and this will require 2 120-volt power adapters. Next is a variation on the idea of a pick-and-place robot, this being the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for this model are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches. It has a weight of just about 6 pounds. And again, this comes in either a 24-volt version with the 26-pin connector and a 2.54 millimeter grid designed for use with the PLC and programming of your choice, or in a 9-volt version, which in this case is not a limited availability. This is a standard model that's available all the time. And once again, this comes pre-wired to a pre-programmed robotics TXT controller, and it does require one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next pair of simulation models focuses specifically on the area of IoT, and were designed specifically for demonstrating and teaching about cloud-based monitoring and control. The models we're going to be looking at now go by the name of Training Factory Industry 4.0, and these are available in both 24-volt versions for use with PLC, and also a 9-volt variation for classroom and demonstration purposes. Now, they've been designed to help address how the recent changes in industrial production, driven of course by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they are implemented on a larger scale. Now, as the following video showcasing the 24-volt version of this model provides a really nicely narrated overview of just how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So here we go.
Fischertechnik Learning Factory 4.0 illustrates process. For a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. Three views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first in, first out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so jumping ahead here. The following topics, just to kind of summarize here, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0 that you just saw. Again, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, this model incorporates many features not found in the models that we previously discussed, besides just most notably the use of the cloud-based dashboard for monitoring and controlling the model itself. Now, some other examples would be things like the camera, which is used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure of the factory floor. The use of NFC chips in each individual workpiece, each of which has a unique identification number, enables the positions of each workpiece in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the networked TXT controllers to communicate with one another. Now, as there are two variations of this model, let's go over what makes them different aside from the voltage requirements. And we're going to begin by focusing on the 24-volt version and what makes it unique. Well, first off, it is a bit of a hybrid in that while requiring a PLC for operation and control, it also incorporates one fischertechnik robotics TXT controller. And in this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud-based dashboard. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which of course is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms like this. Now, in addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this allows for the option of not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these are, of course, they all ship as part of the pre-assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, or pulse width modulation. Now, they also have push-pull output stages for photo transistors and for buttons. Finally, one of the most important new features. Now, unlike any of the previous 24-volt models that we've looked at today, the new 24-volt Training Factory Industry 4.0 model also includes access to a sample program. Now, this program, which is created, and it's first off, it is in structured text format. It was created based upon a Siemens S7 1500 PLC, and this program is available for download on GitHub. Now, of course, the new Training Factory can also be controlled with other PLC models and brands once the end user makes some small adjustments to the sample program. And to enable you to do that, there is also source code available for download from the same GitHub site. Now, as with the first of the 24-volt models we looked at today, the Training Factory Industry 4.0 does have a relay board for multiplayer reversal. And again, both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with pushing connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website, or you can email me directly. Again, I will give you some information on doing that at the end of the presentation, and I'll be happy to get that to you. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all of the other 9-volt versions that we looked at earlier today, these are programmed not using RoboPro, but instead, as they mentioned during the video, using C, C++. Again, all of the programming is preloaded, so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF specifically for the 9-volt model, which I can also make available to you as well. It's also available on the fischertechnik website. Once you've done that, you should be able to get started relatively quickly. Now, the 9-volt version will require the addition of 3 120-volt power adapters because of the way that the connector, the TXT controllers are daisy-chained. And of course, it goes without saying that either of these models will require the ability to access the internet, as well as some sort of tablet or device for accessing the cloud-based dashboard. So, of course, that's a given. You need that as well. Dimensions for these models are approximately 39 by 31 by 16 inches. They have a weight of approximately 51 to 53 pounds, depending on which version. And as with the 2 factory simulation models we discussed previously, we recommend the optional travel case to help protect your model during transport or storage. And that is the Training Factory Industry 4.0 model, again, available in both 9-volt and 24-volt variations. Of course, this brings up the question how much these models cost. And let's take a quick review of each option I've discussed, along with the pricing for each. First off, the vacuum gripper robot, currently only available in a 24-volt version. That is $1,129.95 per unit. The automated high bay warehouse in the 24-volt version it's $1,369.95. In the 9-volt version, with the TXT controller connected, that is $1,318.95 each. The multi-processing station with oven in the 24-volt version, you're looking at $1,199.95 per unit. In the 9-volt version with the TXT controller, you're looking at $1,474.95. In the sorting line with color detection, the 24-volt version is $1,049.95, and the 9-volt version is $1,128.95. The full factory simulation in the 24-volt version is $4,829.95 per unit. And in the 9-volt version with the TXT controllers, you're looking at $5,239 per unit. The conveyor belt in the 24-volt variation, it has a cost of $324.95 list price per unit. And in the 9-volt version, you're looking at $518.95 per unit. The punching machine with conveyor belt in the 24-volt variation is $419.95 each. The 9-volt version is $599.95 per unit. The 3D 3-axis robot in the 24-volt version, $999.95 each, and in the 9-volt version, $1,369.95 per unit. The indexed line with 2 machining stations in the 24-volt version, $1,129.95 each, and in the 9-volt version, $1,394.95 per unit. The Training Factory Industry 4.0, the full factory simulation that you saw in the video, the 24-volt version is $8,999.95. Again, that includes the sample program. And the 9-volt version with the TXT controllers pre-wired, pre-programmed is $9,024.95. Now also available, though, is the Training Factory Industry 4.0 with a PLC connector. So basically, in this case, you have all of the wiring, which, as anyone who's done this before knows, that wiring can be very detailed and it can be time consuming. So in this case, all of the wiring from the model to the PLC connector board is done for you. The power supply is also included. The 24-volt power supply is also included with that. And the cost for that variation is $12,079.95. Also, if you need a variation that includes that connector board, that wiring, and the Siemens PLC, the S7-1500. So essentially, this is as close to getting everything you need as you're going to have available. So this, again, includes the model, the wiring, the connector board, the Siemens PLC, the program. You're going to have your 24-volt power supply with that. You are looking at a cost, if you are in education, purchasing this for an accredited educational institution, you are looking at a cost of $18,499.95 per unit. For commercial use, you're going to be looking at a cost of $20,124.95 per unit. Other items that I've touched upon today, the 120-volt power adapters for use with the 9-volt models. In any case where those are specified, those have a cost of $12.99 each. You will also, of course, need that for the 24-volt variation of the Training Factory Industry 4.0, because it does have that lone TXT controller that, again, helps the model speak to the cloud. So that's $12.99 each. The travel and storage case, which is used for all of the full-size factory simulation models, whether it's the factory simulation models we looked at earlier in the presentation, or the Training Factory Industry 4.0 models that we looked at, any of those 4 variations, this is the case you would use, and the cost for that is $1,524.95 per unit. One other item, breaking news. There is a new model called Quality Control with AI, which you will see here. And the Quality Control with AI model is ideal for visualizing the complex subject area of AI in a very hands-on manner, as it creates a sustainable learning experience by linking theory and practice. And basically what you can see is processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. And essentially what you have here is the sorting line comes with work pieces in 3 different colors. And these workpieces are marked with 3 processing characteristics. So, for example, a part that's supposed to process properly in the white variation, which you see there has a little dot on it. In the red variation, has to have little markings on opposite sides of the disk. And in the case of the blue version, the correct version is going to have that dot in the middle. It's going to have markings on either side. But in addition to this, there are a number of pieces that are created with so-called defects, and you'll see some of those in the bin at the very end there. Things like you have a crack simulation, or you have a dot on a piece that shouldn't have a dot, and maybe one of the side markings missing, or perhaps the dot missing altogether in the case of the blue piece. So what this model is able to do is, as you put it on the conveyor belt, it's got a little camera that basically it takes a little snapshot of that piece, and the AI here judges whether it's, for example, a defective piece. Like you see the piece that's on the camera right now, it's a white piece with a crack in it. So this way it knows that that piece does not go into the white bin, but instead must go into the discard bin at the end there. So this is a really nice model for, again, for learning about using AI applications. And in this case, the training is done in Python. And there are, of course, notes with this and what have you, but it's a great model. I can tell you, we had this on demonstration at a conference that we just did in Detroit, and this one got a lot of attention. So this one is a very popular model. And let me see, what is my cost on this? Because I should probably mention that. You are looking at a cost per unit on this model of $2,089.95 per unit. Just going to show you some of the, flip through some of the slides here on this. See some close-ups. Yep, again, there we go. Currently, it is a 9-volt version only that is available. That is $2,089.95 per unit for the 9-volt version. The 24-volt version is not available at this moment, but we are expecting it in fall. So the pricing and the availability will be coming on that. So at this point, this is normally where I would answer any questions that might come up. I did see a question came up during the presentation, which I wasn't able to answer in live at that time, which was about pricing. And of course, as we've just gone over all of that, you saw the list pricing for all of these units. Of course, I would always ask that for any of these that you please contact us directly. I'd be happy to provide a quote if you're with a commercial entity, or if you're, certain schools, I would deal with that. In certain states, we'll put you in touch with an educational representative who would help you with schools in those states. But in any case, I would always ask that you get a quote. We can put proper shipping and all that on there. So on that note, how do you take the next step? Well, doesn't matter if you would like to, let's say, request a full color brochure, which is available with current pricing. If you have any questions about any of these models you would like to speak to someone directly about, if you'd like to request a quote, as I just mentioned, if you'd like to speak with your dedicated educational representative, depending on which state you are in, if you are if you are interested in getting a quote for a school or an educational institution, there are different representatives who handle that. Again, I do handle a number of states, but I also handle all of the commercial customers as well. So in any case, if you have any questions about anything that we've discussed today related to the simulation models, the fischertechnik simulation models, or anything else of a fischertechnik nature, you can call us. It's the toll-free number here, which is 888-561-7521. You can email us the questions, the quote requests, what have you, at info, I-N-F-O, at Studica, S-T-U-D-I-C-A.com. Or if you have any questions specifically for me that you would like me to address for you, if you'd like the copies of those manuals and what have you, or other information that I mentioned, just feel free to email me directly and I'll be happy to get you that information. My email again is, as you see on the screen, lance.zurek, that is lance.zurek @studica.com. So on that note, I would like to thank you all very much for taking the time to attend today's presentation. Have a great afternoon. We look forward to hearing from you soon. Take care.